Good morrow, 8th grade. In this lesson, we'll be exploring inverse functions and relations. An inverse function is just a relation that maps the x values of a relation back to the y values and vice versa. In other words, it's a relation that is found by interchanging or switching the x and y values. So for number 1 here, if I have the relation of ordered pairs -2, 1, 5, 2, and -1, 4, its inverse is just found by switching your x and your y values around. So the inverse of this relation would be 1, -2, 2, 5, and 4, -1. The same would be true of number 2. The inverse of this set of ordered pairs would be -3, -8, -6, -8, and -6, -3. Okay, so that's what it means to find the inverse of a relation, is to switch the x and y values. An inverse function, when you're given the function in equation format, can similarly be found by switching x and y in the equation, and then, once you've switched those, solving for y. Okay, and we have a special notation for inverse functions. If I gave you the function f of x, then the notation for its inverse function would be f, and we put what appears to be a -1 exponent next to the f, and that just stands for the inverse of f of x. So if you ever see this notation here, it just means the inverse of the function f of x. Okay, so let's go to the backside and practice finding inverse functions given equations, and then we'll do some graphing with those. Okay, so for each of these, we're going to first of all find the inverse of the function, and then we're going to graph both the original function and the inverse. Okay, so the first thing to do when finding the inverse of a function is to switch around your x and your y values. Okay, well, we know f of x is just another way of writing y, so I could make this a y equals 3x minus 1, which would give me the same graph. And now, to do my inverse, I'm going to switch my x and my y around. So that means that x is going to go here, and y is going to go here. Everything else about my equation will stay the same. So this becomes x equals 3y minus 1. Now my job is to solve this new equation for y. So I add 1 to both sides. That gives me x plus 1 equals 3y. And then I can divide everything by 3. And so that gives me the new equation y equals x over 3, or that's the same as 1/3 x plus 1/3. So to write that in inverse function notation, okay, we would say that the inverse of f of x, again, is this symbol here. And that's equal to, again, 1/3 x plus 1/3. Okay, so now I'm going to graph both this function and the original function on this coordinate plane. So let's start with the original function. F of x equals 3x minus 1. Okay. We know that is a linear function, so that's going to give me a line with a y-intercept at -1 and a slope of +3. So it will look like this. Okay, and then the inverse function, I'll go ahead and do in orange. This will also be a linear function, okay, but this time the y-intercept is going to be 1/3, so it's going to be just a little bit above the origin. And the slope is 1/3, so it will be less steep than the original function. And it will look like that. Okay, let's look at number 4 and practice f of x equals x squared plus 1, finding the inverse of that function. So again, you can rewrite this as y equals x squared plus 1. And then we find the inverse by switching the x and the y around. So for this one, that would be x equals y squared plus 1. And now I want to solve this new equation for y. So again, I subtract 1 to get x minus 1 equals y squared. And to solve this equation for y, I just can take the square root of both sides. So taking the square root will get rid of my exponent here. When I take the square root of my left side, I need to be careful and make sure I include my plus or minus sign. Okay, so I end up getting y equals plus or minus radical x minus 1. And so the inverse function notation would be this. The inverse of f of x equals plus or minus radical x minus 1. So if we go to graph our original function now, okay, we know that y equals x squared plus 1 is a quadratic function. Okay, and we can graph quadratic functions by identifying first the vertex. Your vertex formula is x equals negative b over 2a. Well, we see that there is no b value for this one. The b value, in fact, is 0 because I have no x term. So I know my vertex, the x-coordinate of it, is going to be 0 because there is no x term. Okay, if you need to go back and rewatch a video on how to graph parabolas, okay, it is back in Unit 4, I believe. And it should be on the Weebly website. If I just make a quick table of values for this function here, so my vertex is at 0. When I plug in 0 for x, I get 0 squared plus 1. So that would be 0, 1 for my vertex. And then if I pick a few more x values, I could pick positive 1 and positive 2 to plug in. 1 squared plus 1 gives me 2. 2 squared is 4, plus 1 gives me 5. So I have other points at 1, 2, and 2, 5. So this is what my parabola would look like, and then I can always reflect across and have points at negative 1, 1, and negative 2, 5. Okay, the reason I'm showing you this is because when we go to graph the inverse function, we haven't learned how to graph a square root function yet. Okay, that will be the last video we do this unit. But I can take what I know about inverse relations, and we know an inverse, again, just switches the x and the y values on a relation. So I can get the graph for my inverse function by simply switching my x and my y values around from this table. So I'll go ahead and do that down here. To graph this inverse function, all I need to do is create a new table and switch my x and my y values. So instead of 0, 1 for my first ordered pair, I'll have 1, 0. My next ordered pair will be 2, 1, then 5, 2, 1, negative 1, and 5, negative 2. If I now go to graph these 5 ordered pairs, my graph will look like this. And it will actually be a sideways parabola. Okay, so that's how you graph the inverse of a function, either by what you know about your normal functions, quadratics, linears, or by simply making a table of values for the original function, and then you can switch those values around. Okay, moving on to the last page, we're going to determine whether or not two functions are inverses of each other. So to determine that, you need to see if f of g of x, if you're given two functions f and g, if f of g of x is equivalent to x and g of f of x is also equivalent to x. So what that means is, if I were to take these two functions, let's just look at number 5, f of x equals 3x plus 9 and g of x equals 1/3 x minus 3, I should be able to take my f function and plug in g of x for my input. G of x in this case is 1/3 x minus 3. And as a result, I should be able to get x. Okay, so my f function is 3 times x. So that's where I'm going to put in my new input, 1/3 x minus 3 plus 9. And if indeed these are inverses of each other, then this entire side here should simplify to just x. Let's see if that works. So we have 3 times 1/3 x would just be x. 3 times, that should be a minus 3, not a minus 9. 3 times negative 3 is negative 9. And then I bring down my plus 9. Negative 9 plus 9 will cancel, and I just get x. Okay, so far so good. We also want to check that the other way around. So we want to make sure g of f of x, and f of x again is equal to 3x plus 9. We want to make sure g of f of x is equal to x as well. So g of x is 1/3 x minus 3. So I will plug in a 3x plus 9 for x in that function. So this goes back to the beginning of the year when we did function composition in the first unit of the year. So I believe that's also still on the Weebly website if you need to go review that video. Okay, but it's just taking what one side of the equation equals and plugging that into your other equation. So here we have 1/3 times 3x would be x, plus 1/3 times 9 is 3, and then bring down our minus 3, and in fact those cancel and we do get x. Okay, so this means that f of x and g of x, yes, are inverses of each other. Okay, number 6, if we try to do the same thing. So if I take f of x and I try to plug in the g of x function, well in this case g of x is equal to 2 radical x. If I try to plug it into my 4x squared, let's see what I get. Okay, here, so 2 radical x squared would be 2 squared, which is 4, and radical x squared, which is just x. So that would be 4x times 4 gives me 16x. Okay, right away I can see that these are not inverses of each other because this is supposed to give me x, not 16x. So these we would say, without even checking the other, no, they are not inverses of each other. Okay, if you have any questions over this lesson, be sure to jot those down and ask those the next time I see you in class. Until then, have a nice day. You're all wonderful people. Take care.